Atoms, assemble. Welcome to Flash Revision Lab. I'm your tutor, and we'll master this topic in a flash. Today, we'll be diving into the world of atoms, isotopes, and relative atomic mass. First, let's talk about atoms. Atoms are made of protons, neutrons, and electrons. Protons are positively charged with a mass of 1, neutrons have no charge with a mass of also 1, and electrons are negatively charged and have a very small mass of 1/2000. Atoms themselves are incredibly small, with a radius of about 0.1 nanometers. The nucleus is even smaller, with a radius of about 1 × 10⁻14 meters, and contains almost all of the atom's mass. The number of protons and electrons in an atom are always equal because they are both oppositely charged, so their charges need to cancel out in order to form a neutral atom. The atomic number of an atom is the number of protons or electrons and is always the smaller number. The mass number or atomic mass is larger and is the sum of the protons and neutrons. To find the number of neutrons in an atom, you can subtract the mass number by the atomic number. For example, carbon would have 6 protons, 6 electrons, and 6 neutrons as you subtract 6 from 12. All atoms of the same element always have the same atomic number. This is because the number of protons in an atom always tells you what element the atom is. Now, let's talk isotopes. Isotopes are defined as atoms of the same element with the same number of protons but a different number of neutrons. For example, for carbon, there are 2 different isotopes that can exist: carbon-12 and carbon-14. Both have 6 protons as they are both from the same element, which also means they both have 6 electrons. However, carbon-12 has 6 neutrons and carbon-14 has 8. The mass number of an element is not to be confused with the relative atomic mass, which is the numbers that are found in the periodic table. The relative atomic mass of an element is an average value that takes into account the existence of all its isotopes. For GCSEs, relative atomic masses are often shown to the nearest whole number, so they are mostly the same as mass number. To calculate the relative atomic mass of an element, you need to know the mass numbers of all the isotopes that exist, and the percentage abundance of its isotopes. The abundance simply means how common an isotope is compared to the other isotopes of the same element, and usually expressed as a percentage. The formula for the relative atomic mass of an element is the sum of all the abundances multiplied by the mass numbers for each isotope present, divided by the sum of all the abundances. For example, let's say copper has 2 stable isotopes, copper-63 and copper-65. Copper-63 has an abundance of 69.2%, and copper-65 has an abundance of 30.8%. You can substitute these numbers into the formula above to give 69.2 times 63, added to 30.8 times 65, and you can divide this by the sum of 69.2 and 30.8. This will give a final answer of 63.6. And that's a wrap on these topics. Thanks for joining me at Flash Revision Lab. If you found this video helpful, don't forget to like, subscribe, and hit that notification bell for more rapid revision content. If you have questions or need some extra help, drop a comment below or reach out to us on our social media channels. Remember, with Flash Revision Lab, you're just a flash away from acing your exams. Until next time, happy revising!